Good morning, everyone, and welcome to How to Maximize a Virtual Desktop Infrastructure, hosted by Converged Technology Group. From a high-level perspective, we have the following agenda. So we'll spend the next couple minutes reviewing the introduction, going through just a high-level overview of Converged Technology Group, and then we'll quickly transition into the various infrastructure components associated with an optimized virtual desktop infrastructure, namely an optimized network, inclusive of compute, the end-user computing solutions, specifically around the view hypervisor, optimized storage, specifically around EMC, and we'll be focusing on the VNX platform, and then ultimately how to protect the virtualization investment and some of the challenges in that space with protection from solutions from Veeam. With that being said, Converged Technology Group as an organization is a leading provider of co-managed advanced technology solutions who serves customers in the Northeast region. And ultimately, we are recognized as some of the industry's leading subject matter experts in data center virtualization. As an organization, we provide design, implementation, and ongoing support-based solutions. From an ongoing support perspective, ultimately, we represent a solution called CTG Assist, which is what we call our co-managed support. In terms of go-to-market strategy, we talk about three specific lines of business: network infrastructure, unified communications, and the virtualized data center. Within network infrastructure, we talk about a network that's truly optimized for virtual desktop, so therefore there's very specific networking, communications, availability, and performance requirements as it pertains to that network infrastructure. Unified communications, most often we're talking about call control and messaging, and there's very specific considerations within a virtual desktop infrastructure environment to be able to support not only data, which is a traditional application for VDI, but also real-time voice and video applications, and ultimately the virtualized data center solution itself, which is inclusive of the compute, the hypervisor, the storage, and ultimately the recovery solution. From a Cisco perspective, we talk about an optimized infrastructure for desktop virtualization. It's primarily consisting of compute as well as the network components. From a vision perspective, Cisco goes to market around any device, whether it be a thin client computer, a zero client endpoint, a PC, a laptop, or desktop, leveraging either connected or mobile access, inclusive of not only data but voice and video applications in a very secure and consistent fashion. And most organizations that we engage with today not only have the challenges associated with, hey, how do we further reduce operational expense associated with the device proliferation within our environment, but also how do we do it in such a way that we're supporting the incrementing use of voice and video applications in a secure and efficient manner. So VXI is more than just desktop virtualization. It has more to do than just simply application virtualization. In a traditional desktop environment, we gain the benefits operationally as it pertains to scalability and supportability by centralizing the desktop images and the infrastructure in a consolidated data center. But the challenge is that, for the most part, most virtual desktop implementations leverage display protocols which encapsulate not only data, but voice and video or real-time applications. So the concept and the go-to-market strategy as it pertains to Cisco is around preserving the rich media experience as it pertains to voice and video in a differentiated way versus the competition, specifically around unified communications over a network that's truly optimized and secure for the VDI environment. So when we look at an architecture, as it pertains to virtual desktop infrastructure, Cisco's go-to-market term is called VXI, or the Virtual Experience Infrastructure. And ultimately, what that means is that through a combination of data center technologies, borderless network technologies, and what we call the collaborative workspace, we have an inclusive system that's truly optimized to optimize the end-user experience from a voice, video, and data perspective. Within the data center, we have compute elements, and what that means is that you have, for example, the computing or the server infrastructure that's optimized to support the VDI workload. You have, perhaps on top of that, a hypervisor that's optimized for the end-user virtual desktop experience. We may leverage collaboration applications that are real-time voice and video that have very specific needs as pertains to VDI. And then ultimately, as you transition from the data center, these data center services integrate into a borderless network. So from a security perspective, we have elements that provide integrated security within the network infrastructure, and either through content delivery networking or wide area application services, we further optimize the information flow within the network to basically give the most enhanced end-user experience. In the collaborative workspace space, what we have is a number of different options. You have a traditional PC that can run a thin client broker that would connect in and ultimately provide the virtual desktop experience. You have a thin client that can ultimately integrate as a backpack to an existing 9900 series IP phone. You have a thin client option that is a standalone device that can provide that virtual experience solution. And then ultimately, you can have software that runs on a mobile device. So although the CS Business Tablet is end of support, we now talk about Android-based devices and iOS-based devices specifically from Apple. So as we get into the VXI Collaborative Workspace, the full intent here is to be able to take what is a traditional desktop application that might have integrated messaging, voice, video capabilities. What you see here is a Jabber client or a Cisco Personal Communicator that's enabling folks to experience real-time rich collaboration via voice and video. You have a video experience from an active call perspective. And then in the top right, you have a phone that also has integrated video, which is a 9971 series phone. Now, at the end of the day, as we migrate to a virtual desktop infrastructure, the consideration there is how do these applications perform on either a zero client or thin client workspace, and are we able to preserve the quality of service within a display protocol and preserve the rich end user experience? In a traditional voice, video, and data model, and with the implementation of thin client computing, effectively the media flow for voice, video, and data is encapsulated in a display protocol, and what you experience is a hairpinning effect between locations. So on the top right, you see a thin client or an end node that is ultimately trying to communicate to another client or an end node via voice or video. The traditional data flow or media flow would be from that endpoint through the wide area network infrastructure, perhaps through a centralized data center, and then through a wide area network infrastructure to the remote site. Ultimately, through the cumulative latency and without the preservation of quality of service, because ultimately that voice and video is now encapsulated in the display protocol, the end user experience could be compromised. So from a Cisco perspective, through innovations in the virtual experience client, which is part of the VXI infrastructure, effectively what they've been able to do is disaggregate the voice and video flows from the virtual desktop experience, so at the end of the day, we can still preserve end-to-end quality of service while enabling organizations to reap the benefits of a centralized virtual desktop infrastructure. From an any device and anywhere perspective, there's many options that we advise customers to consider. Is the answer simply to extend the life cycle of existing IT assets, such as PCs that are in an environment, so that we can then install a client software agent on that desktop connecting into the VDI environment? Might we already have an investment in Cisco Unified Communications and from a cost perspective potentially benefit from a zero client option integrated into, for example, an existing phone? Maybe there be an opportunity to leverage a zero client option where the end user would now have a data specific experience. Or might we then introduce a software appliance that's truly optimized on a desktop to be able to support voice and video as part of a virtual desktop infrastructure? The other challenge that we face is the ability to support a BYOD policy. So increasingly, we're seeing not only PCs and Macs in the workspace, but we're also seeing the extension of real-time data applications to smartphones and tablet devices. So from a Cisco perspective, the support of the Jabber client within the VXI architecture would enable disaggregation of these real-time applications from the traditional display protocol while preserving the best quality experience for end users in a VDI environment. The idea from a Cisco perspective is that it will be simple, secure, and scalable, and that ultimately what we would gain is simplified desktop deployment and simplified management through a consolidated centralized design. Security is integrated into the solution, so leveraging network-based or integrated security functionality within the network infrastructure, we'd be able to further secure the VDI environment. And then ultimately, we want to be able to invest in a scalable architecture that would scale out as a customer further adopts additional virtual desktops within the environment. Now, one of the ways that we provide a scale-out architecture is through leveraging the Cisco Unified Computing System. This particular platform is the lowest cost per compute with integrated network infrastructure. At the end of the day, when we're looking at different compute options, what we're looking at is the consolidation ratio, or potentially the number of desktops per blade within the chassis, the incremental costs associated with the network infrastructure as you continue to scale out and support more desktops, which are typically absorbed as part of a phased adoption. And at the end of the day, when we're looking at the economics, it's how do we reduce operational expense over the cost of time so that the total cost of ownership of the solution is more cost-effective than the current client-server alternative. So from a UCS perspective, we talk about greater virtual desktop density. We talk about simplified operations in terms of being able to introduce new blades within the architecture using server profiles. We talk about scalability with centralized management to be able to support, if not hundreds, if not thousands of desktops per UCS system. And then there's a very specific innovation around extended memory that allows us to cost-effectively scale as we introduce more memory-intensive VDI sessions. So from an optimization perspective, when we talk about desktop density and scalability, what we're talking about is an architecture whereby we have centralized management and control from network infrastructure components that are part of the UCS system that can scale out as the organization further adopts the various compute elements for their VDI infrastructure. In terms of management, it would be a centralized management interface. We would integrate this network functionality into the current LAN architecture, and ultimately, through the convergence of fiber channel over Ethernet, which is your fiber channel infrastructure on top of your data center Ethernet, we can also gain the benefits of integrating your SAN architecture into that unified fabric to then again reduce some of the infrastructure within the data center and reduce operational support costs. Here are a couple examples of some of the consolidation ratios that we're seeing based on different blades that are supported within the UCS platform. So when we evaluate the different blade options, ultimately we want to know is the applications that are being deployed in that virtual infrastructure, are they CPU bound, are they memory bound, are they disk bound, or are they network bound? We need to make sure that from each of those perspectives that we understand the different use cases and that we account for that in the blade architecture that we choose. An example on a B230 M2 is that we can now support as many as 175 desktops within a single blade within the UCS B-Series chassis. And on the B200 M3 platform, what we see as many as 184 desktops per blade. So based on the architecture that Cisco has leveraged in terms of compute, in terms of their extended memory architecture, which enables us to provision quite a bit of memory per desktop, leveraging not only 8 and 16 gig, but as much as 32 and 64 gig DIMM modules. At the end of the day, using the extended memory architecture, we are now able to achieve 1 and 2 terabytes worth of memory within a particular compute node using 16 gig DIMMs. And when we compare the economics as compared to, say, 32 and 64, the memory scale-out architecture is much more cost-effective using the extended memory architecture within the UCS B-Series as compared to competing alternatives. So from a provisioning perspective, if ultimately we're looking at an impact on operations within IT, we talk about how quickly can we provision either new blades within the scale-out architecture to be able to support an increasing workload of new VDI sessions as an organization continues to grow, as well as those desktop profiles as we support more end users leveraging the VDI environment. So leveraging a technology called Service Profile Templates, what we can do is within UCS Manager, which is the centralized management application for the UCS B-Series solution, what we're able to do is pre-create service profiles that predetermine the network connectivity as well as access to storage and application access. By pre-creating these service profiles, ultimately, in real time, when we add additional blades to UCS B-Series, what happens is that we add the blade to that particular chassis and that the blade itself is auto-provisioned with a standardized template without human intervention. What that enables us to do is provide consistency and reliability in the addition of additional compute nodes within the VDI infrastructure and significantly increase the rapid provisioning of additional scale into the data center for VDI. From a dynamic provisioning perspective, ultimately everything is done within the UCS Manager. And we also have the ability to create very specific service profiles for each desktop. So, for example, if we have a combination of knowledge workers, task workers, and power users, and we have different profiles based on the user type, where one may be very memory intensive, one might be very server intensive or CPU intensive, another one may be very LAN intensive, we can pre-create very specific desktop profiles, create these specific groups, and then at the end of the day, when we add new VDI users into the environment, we simply assign them to the desktop profile groups, and the resources, whether it be LAN, SAN, or CPU, are automatically provisioned within that UCS B-Series to support that VDI client. So again, thereby simplifying the provisioning process, reducing the amount of time it takes to provision new virtual desktop clients, and at the end of the day, reducing operational expense as we scale out using VDI environment. The other area of consideration is on the networking side. So traditionally in a VMware environment, we had some minimal visibility associated with how the network or the virtual network was performing within the virtual infrastructure. And the question became, from a networking perspective, if ultimately an end user experienced network latency or issues with real-time applications such as voice and video, there was minimal visibility into how the network or the virtual network was performing, and therefore IT was at a disadvantage to be able to troubleshoot the root cause of that connectivity issue. So with the introduction of the Cisco 1000V, which is effectively a part of the Nexus platform, ultimately what we're able to do is provide the same Nexus OS type experience from a virtual switch perspective within the VMware environment, thereby enabling IT to gain insight into how the network's performing and effectively perform the appropriate troubleshooting required for real-time multi-service voice and video. Beyond that, in the event that a customer is leveraging some of the advanced technologies such as vMotion within the VMware application suite, the service profile, the network profile, which is inclusive of the port security, as well as the quality of service parameters, actually move or dynamically move in the event that the virtual machine moves around between various ESX hosts within the UCS cluster. So the Nexus 1000V architecture ultimately provides us with increased visibility into the network infrastructure to be able to support these real-time applications. And that capability is done through the Cisco Virtual Interface Card. In terms of prioritization of desktop pools, ultimately what we know is that each end user type requires different amount of CPU, memory, disk, and network performance. And then ultimately we need the preservation of quality of service and bandwidth controls to make sure that these real-time applications basically have the appropriate resources to maintain their real-time functionality. So within UCS Manager and within this architecture, ultimately what we can do is we can create various pools of platinum, say silver, and bronze support. And we can apply different quality of service mechanisms based on the particular pool. So that at the end of the day, that when a particular VDI session falls in a specific pool, that we preserve the very specific QoS parameters to make sure that we meet the very specific end user requirements. In terms of flexibility and bandwidth for converging multiple networks, ultimately what we know is that when you consolidate your virtual desktop workload into a centralized data center, that puts new demands on top of the network infrastructure. The ability for us to aggregate multiple 10 gigabit connections to be able to support on scale that increased load is something that's inherent within the VXI UCS platform. From that perspective, we want to make sure that we can aggregate the bandwidth, that we have the high availability, that we can preserve the quality of service, and maintain active uplinks as we continue to scale out the architecture. Ultimately, it's the dynamic convergence of ports with intelligence that includes the preservation of quality of service that enables us to provide that functionality. Another important item to note is that within that UCS platform, that a converged port that not only supports traditional Ethernet protocols, but also native fiber channel protocols, now gives us the benefit of a converged network infrastructure and ultimately enables us to reduce the amount of networking infrastructure within the data center by leveraging fiber channel over Ethernet over a unified port. Now, in order to make sure that we CTG with the various manufacturers, inclusive of Cisco, EMC, VMware, and Veeam, implement a solution according to best practices, as part of our go-to-market strategy, we leverage validated designs and reference architectures. So from a best practice perspective, in order to ensure that we deliver on the promise of support for multi-service applications on a virtual desktop infrastructure, we leverage those reference architectures to ensure that from a compute perspective, that we have the appropriate architecture and scale, that from a UCS Fabric interconnect, we have the appropriate capacity and manageability. From a distribution perspective, in terms of integrating with the existing LAN and SAN environment, that we have the appropriate distribution switches, and then ultimately that we have enough bandwidth to adequately connect to the storage, which is impacted by the increased demands of the virtual desktop infrastructure. That would conclude the insight and the architecture that Cisco will provide as it pertains to the optimized network and compute for desktop virtualization. And with that, I'll transition to George Mazitris to take us through end user computing solutions.
Thanks, Leo. So when we talk about end-user computing, we refer to VMware to provide us with that virtual desktop experience. Let's take a look at why the desktop model of the past needs to be updated. You in the audience are probably working differently today. For instance, you probably have multiple devices that you use on a daily basis, tablets, smartphones, etc. You probably are able to download apps from an app store whenever you want and begin using and accessing the data and the functionality through the apps almost immediately. Not only is this app available almost immediately, it's also available from anywhere at any time. It's clear that the application devices are evolving in our personal computing lives, yet we are still tied to a specific device and an inflexible computing model at the office. However, we're beginning to see a convergence of personal and enterprise computing, where modern enterprise apps are becoming more user-friendly and available, much like those in our personal lives. These new apps might be delivered via software as a service offerings or through end-user computing models using VMware virtualization and application delivery services. Application delivery models are changing, and to validate that, let's look at the next slide, which outlines the trends in how users are accessing the applications. So as of this year, we crossed the threshold where more enterprise applications are being delivered in an OS-neutral environment, which means browser-based or flexible model leveraging modern frameworks like Java that are being delivered with the requirements for a specific browser or Windows application environment. This highlights the fact that users are accessing information differently, and the trend continues to move away from the Windows into an OS-neutral environment, which further enables us, as end users, to select our devices and methods of accessing these modern and updated applications. This leads us into a discussion of delivering a user experience for the post-PC era, where the platform devices become significantly more flexible than they are today. To begin, let's simplify the model by untethering a user from a specific device and creating an underlying desktop service, which will serve as the substrate onto which we project user-specific applications and services. Next, an application catalog service comprised of modern enterprise applications like software as a service, mobile and legacy window applications. Finally, a data service, which provides an enterprise level of service similar to Box.net, Dropbox, or Google Docs, which can be leveraged to deliver secure access to documents and data anytime, anywhere. To manage this model, we'll use a universal broker service, which is VMware View today, and will potentially evolve into application, data services, and even enterprise mobile device management in the future. In the end, the idea to enable corporate end users to the flexible access and choice of platforms that they enjoy in their personal lives with the security and manageability that our enterprise environments require. With previous releases of desktop virtualization, the target audience was restricted to task-oriented workers of telecommuters. With advancements in VMware View 5 release, the pool of candidates has increased significantly. Technology advancements in WAN bandwidth optimization, voice and unified communications, persona manager, 3D graphic capabilities, and increased client support are opening up possibilities. So let's look at the components that make up a View 5 infrastructure. Starting from left and right, you'll notice the View servers. This is made up of the security server and a connection server. The security server sits in your DMZ as the only component that will talk to the connection server that is sitting inside your network. This allows more of a secured virtual desktop solution. The server in the virtualization stack includes a cluster of ESXi hosts that run the virtual desktops. The network infrastructure obviously provides client access to the environment. And lastly, the storage infrastructure provides high-speed disks that will house the virtual machines. We'll get more into this, more into the storage aspect of this later on in the presentation. So let's take a look at some of the enhancements that came out with VMware View 5. Just like Leo spoke about in the previous section, VMware View delivers a unified communications API, which enables partners to deliver unified communication solutions like voice over IP within the virtual desktop scenario. The UC work is seamlessly passed through the underlying hardware. With VMware View 5, VMware introduces View Persona Manager. View Persona Manager preserves a user profile and dynamically synchronizes them with the remote profile repository. View Persona Manager does not require the configuration of Windows roaming profiles, and you can bypass Windows Active Directory in the management view of the user profiles. If you already are using roaming profiles, Persona Manager will enhance the roaming profiles and the functionality. Persona Manager downloads only the files that Windows requires at login, such as user registry files. When the users and applications open other files from the desktop profile folder, these files are copied from the stored user persona to the view desktop. This algorithm provides performance beyond that achieved with Windows roaming profiles. So VMware View today is supported across major devices with more to come. VMware released native View clients for a wide variety of devices and OSs. Most of you today are using Windows tablets and laptops. Some of the clients that we're seeing are moving towards the thin client model because they don't want to have to deal with the traditional PC and running some type of connection broker on that PC. So by going to a thin client model, there's no moving parts within the thin client. Like in the PC, you have a hard drive, and it's becoming more cost effective for them. In addition, their tablets are being used because, you know, the majority of us use either a tablet or a phone. Why not take these devices, install a client on it, and now I can get my virtual desktop wherever I am. And that's where the tablets are coming in handy. The laptops, traditionally, they're not going to go away. We're going to see the laptops still be a big part of our lives. I mean, a lot of people like to have that keyboard in front of them. Some people aren't used to typing on a tablet. So we're going to see the laptops stay for us for a while. The enhancements in the laptops, obviously, we're going to be using more Wi-Fi cards within the laptops and be able to access our virtual desktop. Some additional things we're seeing in the laptops is turning the laptops into more of a zero client, where we're not using the underlying hard drive, we're booting off of like a flash drive, and then we're booting into our virtual environment through a wireless connection or through some type of air card that's installed on the laptop. And lastly, the desktop delivery model is changing, right? We need to manage this environment differently from a performance and experience standpoint. To that end, VMware is including View Desktop specific information into vCenter management console for ease of managing the new desktop deployment model. So for those of you who are already using VMware and are using vCenter, once you migrate into this VMware View environment, you're going to be able to install some additional features and functionalities onto your vCenter platform, and you'll be able to manage that environment from one location instead of having to go all over the place. All right, so we're going to move into optimizing the storage solution. So in this presentation, we're going to be utilizing EMC's VNX and VNXE platforms. And I'm going to take you through some of the enhancements that the VNX and the VNXE actually create for your VMware virtual desktop experience. So let's look at three key components in your environment today, right? We have applications and the way that they're being developed and deployed, and the way that they're changing from Win32-based apps that run on desktops to portable applications developed on Web 2.0 platforms to be delivered as a service, right? At the same time, we have modern applications that our users need mixed in with older legacy applications that you know, for argument's sake, just won't go away. The reason for IT and end-user computing is to connect users with the apps and the data that they need to do business. Infrastructure is required to deliver and support the applications tier, and that segment of our IT environment is also undergoing rapid changes. As many organizations begin to take on the role of internal service providers, implementing automation, orchestration, and self-service, they are preparing to support an even more elastic infrastructure capable of, with the public cloud providers as an extension of their offerings. Change also makes its way up to the users. Their working environments, demands, devices that they use to perform their jobs. All of this and security and regulations are becoming tighter. Users are demanding a transition from a stale lockdown desktop for laptops, tablets, and smartphones, which better meet their working requirements and styles. So users need to get their data when they need it, anytime they need it, and it's making it difficult to do so when we're behind VPNs, firewalls, and other IT hoops. And it becomes frustrating to the end user, right? So users begin to leverage alternative data access methods like Dropbox, Oxygen, Live Mesh, SugarSync, all of these web-based storage that's available to us through the internet. In addition to that, they're using USB keys to store their data. And to be honest with you, this is outside of a corporate security policy, and it's becoming really out of control. So where does EMC offer the value in this VDI arena? In the VDI environment, there are many different storage needs that must be accommodated. Centrally hosting these requirements allows for flexible, dynamic, and reliable infrastructures that can be protected and secured. The VNX platforms range from both block and file-based capabilities, which allow for each of these needs to be met in a single management domain. So let's look at this slide in a little bit more detail. If you notice, there's the VNX Series and the VNX E Series, right? VNX E Series a little lower on the food chain than the VNX. The VNX E is strictly a file and block over IP unit. So basically it's connected either via a 1 gig connection or a 10 gig Ethernet connection. When we move into the VNX series, we move into the VNX 5100, which is strictly a block level, connects via fiber to your environment. And then we move into the 53 to the 7500s, where these are file and block, also known as universal boxes. These boxes can be file only, they can be block only, or they can be both file and block. So it's they're pretty multifunctional. As we get into the higher models, they're increased in memory, processor performance, as well as disk capacity. So we can add a lot more disk to a VNX 7500 than we can a 51 or 5300. So where does EMC offer the value for VDI? Lower the cost using fast technology, protect the data with EMC software application suites, ease of management using Unisphere, proven architectures in both the VNX-E and the VNX line products, pre-architected solutions, security and compliance, and lastly, CTG's consultant expertise. So how does EMC solve the problem of balancing cost and performance to achieve the positive user experience? This is simple, right? Fast and fast cache. So let's look at the benefits of flash and in the VDI workload. SKU is a very important concept. Understanding that 90 to 90% of an I/O generated in a VDI environment actually running on 5 to 10% of the capacity enables us to approach with this new type of thinking. Why spend a lot of money to put all the desktops on high-performance storage when only 10% of the capacity required requires that level of performance, right? So EMC Fast Cache and Fast VP allow us to use enterprise flash drives for high performance when it makes sense, and to use higher capacity, lower cost storage for the majority of our workload. Fast pools don't really help much with the link flow model, especially if the refresh time is frequent. That's why Fast Cache is the recommended solution. Now let's look at the benefits of fast when using a persistent desktop. The dynamic nature of a virtual desktop actually has some pretty predictable behaviors. And the first is the normal 250 meg of desktop capacity, where the majority of the IOPS are generated. In the link clone model, much of the I/O comes from the replica during the boot and logon, and the transactions to the link clone. In the persistent desktop, that model expands the capacity, but the percentages stay the same. When it changes in that, what changes in that we now have to account for is the loss of the replica or the master image in the Citrix world. Why is fast pools? Which is why fast pools will help significantly in a persistent desktop. So we all want to save money, right? And we can achieve this goal as a bonus to improve the user experience using fast, right? Let's look at the slide starting from left and right. Without fast, DRAM can only help about 1 out of 5 IOs. With fast, 9 out of 10 IOs can come from cache. The other one of 10 of them need to go to disk. When combining fast tiering and persistent desktop, and a persistent desktop, even lesser workload has to touch the spinning disk, as shown to the far most right section. So now that we have decided that we like the idea of the next generation desktop and want to start down the path of transformation, what do you need to know to be successful in this? So what I'm going to do now is I'm going to take you through a scenario, right, through a tested design that has been proven out by EMC. It's going to go through the disks, the way that they're carved up, and the performances on each of the tasks that can be performed within VDI. So the basic storage layout for the reference architecture: 15 SAS drives, linked clones and replicas, 14 drives for user data, and 5 drives for virtual servers required for the infrastructure. The rest of the drives made up of hot spares, fast cache, and OE drives. So let's talk about Bootstorms, right? This is a huge, huge topic when we talk about virtualization, right? So they're not all that common, but they are normally triggered by some administrative failure, right? So think of a bootstorm when all of these machines, all these virtual desktops that run in your environment have to reboot for some reason or another, right? That causes what we call a bootstorm, right? Desktops are normally booted up when the user logs in. However, in a brutal use of resources, and many customers that use this as a worst case scenario, right? So we look at this as, when we design this out, we look at Bootstorms as, let's say, the worst case scenario. What happens if all these users boot up at the same time? In the slide, the story of Bootstorms plays out as we demonstrate that SAS drives is working pretty hard, but still maintaining a decent response time. But when you see the replica run stay below 1 millisecond and a linked clone stay below 6 milliseconds, the effects of fast cache and DRAM cache are seen. Keep in mind that the replica in this reference architecture is not pinned to EFD disks, but rather lives on a fast cache. All right, login storms. So in the morning, we look at login storms, people logging in within, let's say, a 60-minute period over, first thing in the morning. And we reference that as being a login storm, right? So this chart is actually depicting somebody logging in over 60 minutes, 1,000 users actually. And this usually occurs, like I said, in the morning when people are coming into work. The login storm is more likely a scenario for customers to experience on a regular basis. And in this model, we can see the replica LUN continues to service and read through the login storm, and how the writes and the level, they level themselves out over time. Recompose. I'm not sure how many people are using VMware View right now that are on the call, but when there are times where we actually have to recompose our base image, right? So when we recompose in the VMware View world, basically it's because we've added an application to the master image, and we want to push that application out to all of our users. So what we do is we do a recompose on the virtual desktop environment, right? The recompose is done by an administrator within a View administrator interface. With this function, administrator can change the snapshot within the parent VM or change to another parent VM. In both cases, a new replica image will be provisioned to all the LUNs configured within the pool. So if you look here, in our scenario, we did a recompose, and you'll look at the writes and the workload of the writes that have taken during this recompose, and you'll notice that the fast cache is now servicing 8,500 IOPS at the peak, and then it's just tapering off the end. So view refresh, right? During the refresh, the snapshot to the parent VM is not changed. This action only resets the delta disk of the initial state to the source. This is done to reduce the amount of storage used by the virtual machine. This operation is important in some organizations who want to perform frequent refreshes to the desktop. In this demonstration, all of the desktops were refreshed, and there were no performance impacts, and the response time was well below the acceptable threshold. So net effect, 60% lower storage cost, 40% more disk IOPS, 66% less power and cooling, and 70% fewer disk drives. All right. So how are we going to protect our environment? So in this scenario, we want to maintain and guarantee uptime of our VDI solution. We need to first make sure we have the tools to do it. What we like to use and propose to our customers is Veeam backup and replication to provide fast, flexible, and reliable recovery of virtual applications and data. It unifies the backup and replication in a single solution for both VMware, vSphere, Microsoft, and Microsoft Hyper-V platforms. Now you can leverage the power of virtualization with a product built strictly for virtualization. So when we look at Veeam, we shouldn't just focus on the backup aspect of the application. Recovery is our primary focus. Think about it. How often have you tested your backups to see if they actually work? Better yet, what would it take for you to do this sort of testing? What if the recovery testing can be done at any time of the day while production systems are running? Let's compare a traditional backup to a Veeam backup. Traditional backups, agents in each VM, full VM recovery is complex and tedious, they're expensive, and they don't guarantee us recoverability. Veeam backups, agentless, instant VMware recovery, cost-effective, and sure backup verification. So here are some of the standard features you'll find with Veeam backup and replication software packages. Image-based backups with 0 agents, application-consistent backups of VSS, brick-level restores and capabilities, instant VMware recovery, file level, application item level, full VM, automatic backup verification, isolated virtual labs running in backed up VMs, built-in replication. So when we think of when we look at Veeam, we're looking at reliability, fast, and buying you time, right? So this slide is actually pretty good because it tells the story of how Veeam actually works. So basically what it's trying to depict here is in a scenario where, let's say, a user were to delete something off of their Active Directory, okay? And this happens at times, right? You know, you get an administrator in there and they do something that causes a user to be deleted, or maybe a piece of the user's profile to be deleted, right? With Veeam, as long as we're backing up our Active Directory, our global catalog, we're able to go into that global catalog on the backup. We're able to run a tool against it and pull out a piece of the schema, let's say just the user information, and bring it back into our production Active Directory. No reboots, no downtime, no loss of data, nothing. Users continue to work the way they do, and they log in the way they do. And that's really where Veeam shines in this in recovery. Sure backup, Sure backup can automatically verify the recoverability of every backup every time, right? Test backups by running virtual machine backups from isolated virtual lab. With the new distributed architecture, we have better performance with lightweight proxies that act as data movers, simplified deployment and maintenance of remote large-scale installations, and we allow more efficient replication over the WAN. So according to research, 10-to-1 reduction in number of restore steps and secure delegation. We look at this as a one-click file restore. So this image here is depicting the web-based tool for Veeam. This is a web-based restore, and basically what we're able to do is we're actually able to go into our backups on the file level. So when we back up a virtual machine as a whole, let's say it's a file server or even an Exchange server, we can actually go into that server and we can remove one file out of that, that backup. Even though it's doing an entire image-based backup of the machine, we can go into that machine through the backup and recover one file that's been lost. Again, this is the web-based interface. There is an actual fat client that can sit on a machine as well, so you can use that. But note that this can be done via the web. So restore directly to original locations. No need for network connection to the VM, user permissions on the server of the VM, and agents in the server of the VM, right? So delegated operator does not need permissions. Veeam proxies the request through the backup server using the credentials supplied for guest index. So let's look at the replication model on the slide, right? If you plan to use DR strategy with Veeam, then the following picture should serve as good reference. It really doesn't matter if you have one host in the DR site or if you have several ESXi servers in vCenter too. Using Veeam backup proxy and at the DR site allows Veeam to send replicated traffic from the backup proxy to your main site across the WAN to the backup proxy in your DR site. Then the DR site backup proxy can push the data down to a SAN or a local storage through, without using the ESXi's kernel. Cost-effective replication, less expensive servers for standby, storage agnostic using Tier 3, less expensive storage at DR sites, whole VMware backup application, and it's non-specific, okay? Compression deduplication, reduce the volume of backups and data, include at no additional cost, include synthetic full backups to control the growth of backup files. So built into this, into the solution with Veeam backup and replication, we have the ability to do deduplication on our backups. And in our case, when we deploy this for our customers, we've seen a reduction of over 50% in the backups. So backing up a 2 gig data store with, let's say, 30 virtual machines, we've seen the backups come out maybe under 500 meg. Because of the way that Veeam does its compression deduplication, we've seen these great numbers. In addition to that, once we do our full backup, we can do synthetic fulls and allow that data to also be small as well. And that's it.
Okay, so hey folks, we understand that we have provided you with quite a bit of information, but ultimately what we want to emphasize is the fact that when you're considering virtual desktop, it's really an infrastructure or an architecture that most of our customers invest in over time. The significant implications on the network in terms of the performance required to support a VDI infrastructure, in addition to real-time multi-service voice and video applications that would reside or be executed upon within either a thin client, zero client, or a desktop broker environment. Ultimately, you have the various choices as it pertains to the actual end client, right? So being able to navigate through what combination, more often than not, of thin client, zero client, and PC-based solutions as part of the VDI infrastructure is an area that we can help. From a compute perspective, above and beyond the network infrastructure, whether it be leveraging a very cost-of scale-out architecture using the UCS B Series platform, one, from the scale-out design leveraging a centralized network and centralized management, or two, even as compared to the likes of an HP, for example, being able to leverage the extended memory architecture, scaling out to as much as 2 terabytes within a particular node using 16 and 32 gig DIMMs versus more costly, say 64 gig DIMMs in order to be able to scale out to that memory. Again, the economics very much work in favor through that innovation in favor of Cisco UCS B Series platform. There's the significant considerations as it pertains to the end-user computing solution. So with VMware View and the specific innovations in vSphere 5, we feel that we are able to further optimize the end-user experience through that latest release. At the end of the day, we understand that there's a number of different storage options out there as it pertains to supporting a VDI infrastructure, but the VNX Unified Storage Platform, with the flexibility to support either block level or file and block within a unified storage platform, ultimately being able to understand what platform makes the most sense, what is most cost effective, can we leverage fast technologies and different drive types to be able to meet the I/O requirements of VDI as well as the capacity of data within that data center, and ultimately making sure that we have a scale-out architecture that can also expand to include any sort of disaster recovery and business continuity. And then at the end of the day, knowing that, hey, there are impacts on our current backup strategy, and that by leveraging Veeam, that we'd have the ability to ensure the integrity of our backup, ensure the integrity of our ability to restore those virtual machines, be able to, through either web-based or client-based access, simplify the restoration process, thereby translating to IT operational efficiency in the most consistent manner possible. So from a CTG perspective, there's a few key things that most of our customers come back to us and say, hey, you know what, at the end of the day, when we have choices as it pertains to partners, why do we choose Converged Technology Group? So one is the exceptional customer satisfaction rating. So I don't know that anybody can identify any perfect company, but at the end of the day, we have some proof points as it pertains to Cisco, for example, the largest networking manufacturer in the world, that we've, out of several thousand partners in the Northeast area, had been awarded the East Customer Satisfaction Excellence Partner of the Year. And we maintain a very close eye on customer satisfaction. And in the event that there are any issues, we would jump on it very quickly. And we maintain that level of customer satisfaction focus by that gold star of excellence that's next to our name within the Cisco Partner Portal. In terms of industry experience, it takes a very unique blend of advanced technology, systems integration skills to be able to integrate these solutions seamlessly and realize the benefit of a VDI architecture. So we classify ourselves as a complex systems company. In terms of advanced technology, 74% of the technologies we represent are complex. That typically means there may be some implied business risk, but at the end of the day, most organizations today are attempting to leverage some of the most leading-edge technologies for their unique and competitive advantage versus their competition. So we have over 14-plus years experience in the networking, unified communications, and virtualized data center space in order to be able to ensure an effective implementation as well as ongoing support. We offer complete lifecycle services. So from a design perspective, whether it be value-based engineering from a pre-sales perspective, the actual detailed design, which is an early phase within our implementation services, the continued operational support through CTG Assist, and then optional components within CTG Assist, which includes network optimization services to ensure that the network is not only up, but is still performing to its best ability as the IT asset progresses through its life cycle. In addition to the East Customer Satisfaction Excellence Partner of the Year, we've been named the Cisco East Services Partner of the Year, specifically around that CTG Assist offering. From a partner ecosystem perspective, we have various partners, Cisco, EMC, VMware, and Veeam, right, would be considered to be our top partners, and our people ultimately are our differentiator. It's the constant investment in new skills acquisition to bring exceptional value to our customers. It's our PDP, or personal development planning, that enables us to commit and execute against those skills development. And ultimately, culturally, it's the passion for continued customer satisfaction excellence. When we look at our partner ecosystem, for the most part, it's Cisco, EMC, VMware, Veeam. Certainly we have competencies in Microsoft, APC within the data center, Accelerate in terms of third-party application integration as it pertains to unified communications, and occasional instances where we partner opportunistically with HP. With that, I'd like to transition over to Michael Toscano, our VP of Sales, to field any questions that might have come up along the webinar.
Thanks, Leo. As Leo stated, we covered a significant amount of information today. So at this time, what we'd like to do is open up the session for questions. Please use the Q&A drop-down box at the top of your screen to submit questions. I know we have a few in the queue, so let's get started. First question from the audience is, how fast can I spin up a virtual desktop?
Okay, so when we design our virtual desktop infrastructure, we carve up the storage in a certain way to allow, like I said in the slides, for Bootstones and login storms and things like that. So when you're creating these persistent disks and these linked clones, we try to use RAID 10 technology within our ESX environment, and it allows for these virtual machines to spin up immediately. Now, in the event, let's say that you're using VDI and an end user calls you up and says, hey, my VDI is not working, I have a virtual machine that went down, how do I get back on? You can actually go into the pool and you can create an additional virtual machine onto that pool, and immediately it'll start to create that image. Within 5 minutes, the user's back on and up and running.
Super, thank you, George. Next question, can I store sensitive data locally?
So we try, when we're building out these VMware virtual desktop environments, we try to use a best practice methodology, and that would be to store your data on a SAN. So we try to do redirection using either VMware's Persona Manager or using group policy to redirect all the data to a shared storage, and from there we back up that shared storage.
Another question, when should I not use desktop virtualization?
So there are certain applications where desktop virtualization just doesn't work, right? Some type process-intensive applications or real video-intensive applications can cause problems. We try to, with the latest version of View 5, we have seen 3D graphics work extremely well, where we can do rendering, and it does work out very well. But there are instances where the processing and video just is not going to be supportive within the VMware Virtual Desktop. So, we do some testing prior to coming up with a solution for you that actually will tell us whether or not these applications are going to work.
Great, thanks, George. I know we're winding down on time, so we'll take one additional question. And the question is, assuming that this does not require additional Microsoft licenses?
Yeah, so it uses, basically it uses your existing Microsoft licensing, depending on what you're doing. So for example, if you're going to maintain a laptop that's going to run an application as to do the connection, you'll use a Microsoft license for that laptop. In addition, you're going to use your virtual desktop license as well, so that's an additional license. When we go into thin clients where we use zero clients or things that have Linux operating systems, we don't use a license on the underlying OS. It's just using your Windows-based licensing, so you shouldn't need any additional licensing at that point.
Thanks, George, and that will conclude our question and answer session. Any questions that haven't been addressed have been captured by Converged Technology Group, and we will follow up with one of our representatives. At this time, I want to thank you for your time and participation. I will turn it back over to Anthony Malley.